Hello class, Transformational Geometry once again. This is part 5 of our video series on Transformational Geometry about what is it and what do we need to know. In part 5 we're going to talk about dilations. Now that's not dilations but dilations. So a dilation by definition is a transformation that enlarges or reduces a figure. Okay, so it takes a smaller figure and blows it up into a bigger one, or a bigger figure and reduces the image into a smaller one. So, on the two questions that we've been looking at, does it have an impact on congruency? Yes, it does, because these two figures are not congruent to each other. Does it have an impact on orientation? No, it doesn't, because this figure right here, this point, is on the top left. Its corresponding point in the new figure is also on the top left, so it doesn't have an impact on orientation. So let's find out how to actually perform a dilation. Okay, so we're going to take a figure. So let me get a figure. Let me draw one. Okay, we'll draw a rectangle this time. So we've got a rectangle that's right here. That one looks, let's go about right there. Looks pretty good. Okay, now the first thing that we need to do on this figure is we need to identify each of the coordinates. So I'm going to say that this point is A, B, C, and D. Okay, so point A is found at 2, 1. B is found at 2, 1, 2, 3, 4. So 2, 4. Okay, C is going to be found at 1, 2, 3, 4, 5, 6, 4. And D is going to be found at 6, 1. Now what we need to do on this is we need to dilate this one, and this one in particular we're using a scale factor of 2. So in order to do a scale factor of 2, what I'm going to do is I'm going to take each value inside the coordinate and multiply it by 2. So our A prime, or the new point for A, I'm going to take this 2 and multiply it by 2 and get a 4. We'll take this 1, multiply it by 2 and get a 2. And I'm going to do that with each of the points. So you should end up with B prime then equaling 4, 8. Then C prime equaling 12, 8. And then D prime equaling 12, 2. And now if we were to plot each of these points, we will have our dilated figure. So A is at 4, 2. So I come out 4, go up 2, place a point. Okay, go to B, goes out 4 and goes up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then C is 12, 8. So that's 4, 5, 6, 7, 8, 9, 10, 11. This is where it would actually be, about right here. It's a little bit bigger than the graph that I have. Okay, and then the last one would be at 12, 2. Okay, so if I were to connect these points, I now have a figure that has been dilated. Okay, so now in order to figure out that scale factor and figure out what it does algebraically, we need to look at what happens to each of these points. Okay, so if I were to take this first point again, this is my original point, 2, 1. What did I do to each of these values, the 2 and the 1, to get a 4 and a 2 out of it? We multiplied it by the scale factor. So we took our original point and I just multiplied the x value by 2 and I multiplied the y value by 2. And that is how we use a scale factor of 2. Well, what if it were a scale factor of 3? Well then, instead of having the 2 in those spots, I would have a 3. What if I had a scale factor of 9 over 5? Well, then you would have 9 over 5x and 9 over 5y. And what we need to understand is that if I use a scale factor greater than 1, then my new image is going to be bigger than my original image. So if the scale factor is greater than 1, the new figure will be bigger than the original. So what happens if it's smaller than the original? Okay, well, what if we multiplied by a scale factor of 1/2? Okay, well, if we took that same figure that we had in the last one, so let me see if I can get that figure back. And I believe that figure was about like this. Let's go back and look at that one and see. So we had, so it was a 4 long and 3 tall. We started at 1, 2. Okay, so this one's a little bit big. Okay, so let me shrink this one down. I think 4 long and 3 tall. 1, 2, 3, 4. Good. And so this one's now the same thing. Now, what if I took this figure and did a scale factor of 1/2? Well, what would we do on this one with all those points that we did have? The 2, 1, and the 2, 4, and the 6, 4, and the 6, 1. What I would do instead of multiply by 2, I would divide by 2. Okay, so if we look at point A as 2, 1, my A prime would then actually be 2 divided by 2, or half of 2 is 1, and half of 1 is 0.5. Now I take my point B, which was 2, 4, I cut each one of those in half, and I would end up with my B prime being 1, 2. And then my C prime, okay, we had 6, 4, so we would cut each of those in half, and we would end up with 3, 2. Okay, and then our D prime, we go back to the original, and it was 6, 1, so that means I would end up with a 3.5. 3 and then 0.5. Okay, so if we were to graph these points, we've got 1 and then 0.5 would be right there. And then 1, 2 would be here. And then 3, 2 would be here. And then 3.5 here. So when I multiply by a scale factor less than 1, I end up with a figure smaller than the original. So in this one, if we look at the algebraic representation, what did we do to the x and the y values of the original coordinates? I divided them by 2, or I multiplied by 1/2. So you'd have a 1/2 x and a 1/2 y. And that's how we end up with scale factor, and we end up with dilations. Dilation is the only one where we're going to be multiplying a coordinate by a number. And that's how you can recognize it in a problem. Okay, that's how we recognize it. Okay, so that's dilation. So that's the end of our video series on transformational geometry. Hopefully, if you go back and watch all 5 of them, you will learn a little bit about each of the transformations.